Okay, now let's look at one of the problem caused by summary route. Okay, that is, it may cause a routing loop. Okay, let's look at this as an example. Okay, so here we have R1 and R2. R1 is connected to the ISP, so R1 have a default route. Okay, there's a default route here that goes to the ISP. Okay, next, now, okay, R1 send a routing update to R2. Okay, telling R2 that I have a default route. Okay, so now R2 create a default route. Okay, 0.0.0.0/0. Okay, and it will points to R1. Okay, now let's look at R2 now. R2 is connected to 172.16.1.2 and .3. Okay, so R2 send a summarized route telling R1, I have a connection to these three networks. Okay, and because now it's a /16, so it includes more than these three networks. It also include .4, .5, all the way to .255. Okay, although all these networks are not connected, but because of the summary route, R1 will think that all these three networks from .1 all the way to .255 is connected via R2. That means R2 have a route to go to all these networks. Okay, now the problem comes when R1 receive a packet. Okay, let's say R1 receive a packet that's 172.16.4. So who will R1 send the packet to? Okay, R1 will send it to R2. Okay, why? Because R2 send a summarized route, and the summarized route tell R1 that he have connection to 172.16.0.0/16, and this network include 16.4. It includes 16.4. So R1 will pass the packet to R2. When R2 receives the packet, okay, and he will check, hey, I do not have a connection to 172.16.4. I only have connection to 1.1, .2, and .3. So I can't find a route going to this 172.16.4. So what will the R2 do? Because he can't find a route in the routing table, he will use the default route. So he will pass the packet back to R1. And when R1 receives the packet again, of course, he will pass it back to R2, and R2 will pass it back to R1. And hence, this will result in a routing loop. Okay, so the packet will loop between R1 and R2. Okay, so this is a summary of what I have said. Okay, so R1 have a default route that goes to the ISP, and R1 tells R2 that I have this default route. And so R2 create the default route, okay, in R2 routing table. Then R2 routing table also contain these three networks, route to these three networks, .1, .2, and .3. And because we turn on auto summarization, R2 will send a summarized route to R1, saying that, okay, I have this connection to this network, which is a /16. So it will include from .0 all the way to .255. Okay, although R2 only have connection to .1, .2, and .3. Okay, so R1 will install the summary route, okay, the /16 summary route, okay, and say that if R1 receive a packet going to this network, you will send it to R2. Okay, then the problem comes when R1 receive a packet that's going to 172.16.4. Okay, because R1 have a route going to this summarized network, you will give it to R2. When R2 receive the packet, okay, then he will look at his routing table and could not find any match. So because he couldn't find any match, he will forward the packet back to R1. Okay, why? Because of the default route. Okay, so hence this create a routing loop. Okay, the packet that is going for this 172.16.4.10 will route between R1 and R2, R1 and R2 until the time to leave of the packet dies. Okay, this slide shows how EIGRP resolve the problem of a routing loop. Okay, EIGRP by default, okay, when they send a summary route out, okay, so they send a summarized route out. Okay, the EIGRP will also create a null zero route. Okay, it will be created automatically, okay, inside the routing table. Okay, so let's say R3, okay, send a summarized route, Okay, so R3 have a summarized route out. Okay, and R2 also send a default route to R3. So R3 created a default route. Okay, and R3 is connected to these three networks: 172.16.1.2 and .3. Okay, this is the one that R3 will automatically create. You create a 172.16.0.0/16 route. Okay, and it will go to now 0. Okay, so this is created because R3 sent a summarized route to R2. So because it sent a summarized route to R2, you also create a 172.16.0.0/16. Okay, and it will send to now 0. Okay, what is now 0? Now 0 is actually a rubbish bin. Okay, what it means is whenever R3 receives a packet going to this network, and if it can't route it, it will send to the rubbish bin. That means it will throw away the packet. Okay, let's see how it works now. Okay, now, okay, R2, let's say R2 receive a packet, and the packet goes to 172.16.4. Okay, because of the summarized route, R2 will send the packet to R3. Okay, R3 received the packet, and the packet is going to 172.16.4. You look at the routing table. Okay, so you try this: 172.16.1, no, it cannot. 16.2, cannot. 16.3, cannot. Okay, instead of going to the default route, which will pass the packet back to R2, okay, because of this route, okay, R3 got this 172.16.0.0/16 now 0, okay, route in the routing table. Okay, this, because of this, he will send the packet to the now 0 interface. Okay, because 172.16.4 is actually part of this network. Okay, what happens when the packet go to now 0 interface? Okay, the packet will actually go into the rubbish bin and get thrown away. Okay, it was discarded. Then this prevents the packet from routing between R2 and R3. Okay, this is done automatically by EIGRP if you turn on auto summary. Okay, this is in summary what I will explain earlier on. Okay, there's some typo over here. Okay, over here, okay, this should be R1 and this should be R2. Okay, in order to match the description over here. So just make the change in your slides. Okay, so over here, R1 have a default route. R1 send the routing update to R2, and R2 install the default route from R1, and R2 also contain route to 172.16.1 and 172.16.2 and .3. And R2 install the summary route. Okay, this is something that is new. Okay, compared to the earlier one. Okay, because of the now 0. Okay, so R2 install the now 0 summary route in the routing table, and at the same time, it also send the summarized route to R1. Okay, so R1 install the summarized route. R1 receive a packet going to .4, and they pass it to R2 because they have this summarized route. Okay, and when R2 receive the packet, it doesn't match any of the subnet that it has because it only have .1, .2, and .3. So what will you do? Okay, you will send the packet to now 0, and because it's a now 0 interface, the packet is discarded instead of sending it back to the default route. So this prevents the packet from going into an endless loop.